Hello everyone. In this lesson we are going to see how to solve right-angle triangles using primary trigonometric ratios. Please make sure that at the end of the video you come and check your understanding with I can statements and make sure that you are able to label the triangles as opposite, adjacent, and hypotenuse with the relation of the related acute angle. You can determine the primary trigonometric ratios and use those ratios to solve a right angle triangle and set up the proper ratios with the given information and know when to use the inverse ratios. Okay. Before we see all this, we're going to go ahead and recall Pythagorean theorem. Okay. Pythagorean theorem, as you know, can be used only on the right angle triangles. And we can use Pythagorean theorem when we have two given sides and the third side is missing. It can be any of the three sides, right? Another way how we label the two shorter sides of the right angle triangle is either sides or legs, so we can interchange this kind of labeling as we move forward. Pythagorean theorem states that the sum of the square of the two sides equals the square of the length of the hypotenuse. Okay. This labeling is if the triangle is labeled A, B, C, so A squared plus B squared equal to C squared. And just a short recall here, how we label the triangle using the lowercase letters. We use the same letter as the one that is used to label the angle. In this case, this angle here is labeled A. Therefore, the opposite side will be side A. Right angle is labeled with C, so that will be side C. And the third angle is labeled as B. Therefore, the side opposite that angle will be lowercase letter B. Okay, so we use lowercase letters for the sides. Based on the given information here, we have the hypotenuse 100 centimeters and one of the sides 60 centimeters. From this, from the equation here, we can derive that the missing side AC, let's change that to C here, not AB, AC, equals the hypotenuse side C minus the given side A. Okay, so all this squared, so C squared minus A squared equals to AC squared, or angle side B squared. Plotting into this equation the given information, hypotenuse 100, the other side 60, we get, after simplifying, we get that x squared, or the missing side squared, equals 6,400. Now we're not looking for x squared, we're looking just for the side of x. In order to get rid of the square, we're going to take the square root of both sides here. Okay, from where? To the right side, square root of x squared equals x, square root of 6,400 equals 80, side AC is 80 centimeters. Okay. Recall, Pythagorean theorem can be used only on the right angle triangles, and in order to use it, two sides must be given. All right, now let's recall the primary trigonometric ratios. As you know, there are three of them: sine, cosine, and tangent. Sine is written as the ratio of the opposite over hypotenuse, cosine as the ratio of adjacent over hypotenuse, and tangent as the ratio of opposite over adjacent side. Okay, now what do we mean and how do we label these triangles is very important, is very crucial. First of all, we have to indicate the angle that we write in the ratio. For which angle are we writing these primary trigonometric ratios? And based on that angle, we're going to label the triangle as opposite, adjacent, and hypotenuse. And again, primary trigonometric ratios are written only on the right angle triangles. Let's label the given triangle here as opposite, adjacent, and hypotenuse. Here the given angle is this angle here, labeled theta. Based on that angle, now we're going to label this right angle triangle. Opposite angle theta is this side here, opposite. Adjacent is the side connected to the given angle, and hypotenuse is the other side connected to the given angle that is opposite the right angle of the triangle. Okay, so hypotenuse is very easy to identify and to label. Be careful when you label the adjacent and opposite sides, as is very important to be accurate when you label a triangle, because that's going to lead you to write the proper trigonometric ratios. Okay, so one more time, you indicate what is the given angle. Label the hypotenuse first, and then opposite the given angle is the opposite side. The next or the other side of the that is the arm of the given angle is your adjacent side. Let's practice this on this triangle. Okay, we have triangle DFE, and we need to write the three primary trigonometric ratios for angle F. So this is very important to indicate which one of the angles. Okay, angle F here, this is the right angle, angle E is the right angle, which makes this side the hypotenuse. So let's label this H for hypotenuse. Opposite angle F is this side here, so we're going to label that with letter O. And adjacent, the other arm of angle F here, we're going to label that as A. Okay, now sine of angle F is opposite over hypotenuse, 8 over 17. Pretty straightforward after. So that's why labeling the triangle is very important. Cosine of angle F is adjacent over hypotenuse, 15 over 17, and tangent is opposite over adjacent, 8 over 15. Okay. Now, as I said, because this is so important, I want you to choose 3 on the handout that you have labeling triangles. I want you to choose to stop this video and choose 3 of those triangles and label them. In order to use the primary trigonometric ratios, we need to use the calculator. I want you to be comfortable to use the calculator and know how your calculator works. Some of them work forwards and some backwards. So make sure that you do check with your calculator. Do know how your calculator works. First of all, in this unit, make sure that the mode of the calculator is in degree, not in radians. Then see if your calculator works backwards or forwards. Forward means that if you type in sine 60, then you're going to get an answer, whatever, well, in this case, it's going to be 0.8660. If you get an error, that means that your calculator is not forward, but is backwards. That means that you have to write the angle first, then the primary trigonometric ratio. You're going to get the same answer. So please make sure that you do know how your calculator works, because otherwise we won't be able to work without the calculator in this unit. Okay, another thing that I need you to be aware is that when we use primary trigonometric ratios in right triangles, we're always going to deal with 3 information. 2 of them will be given to us, and we're going to solve for the third one. Based on the labeling that you're going to have, you're going to check which one ratio is the most appropriate one. And you're going to create this kind of a triangle here. 2 of them, for each case, 2 of them of this information will be given to you, and the third one will be missing. In order to write the proper ratio or the equation, cover the letter that is missing. For example, let's say you are going to use sine ratio, and opposite is the missing side. Then opposite will be sine of a given angle multiplied by the hypotenuse. If you're going to use cosine and hypotenuse is the missing information, then you are going to have the equation hypotenuse equals opposite over cosine of the angle, given angle. Okay, so understand how you can use these triangles to solve right angle triangles. On the examples that we're going to look, we either going to solve for the missing side or for the missing angle. And here are the steps that we're going to follow if we're solving for the missing side. Okay, the very first thing is properly labeling the triangle. Okay, after you've labeled the triangle, you have to identify which ratio you can use. After you identify the ratio, substitute the known values that are given to you, then use that ratio to solve the triangle. These pyramids will help you to use the proper ratio and follow through. Now let's illustrate what we talked about with this example here. We have triangle ABC where the hypotenuse AB is 12 centimeters and angle B is 25 degrees. The very first thing that we need to do, as we mentioned earlier, is to label the sides of the triangle as opposite, adjacent, and hypotenuse based on the given angle. Our given angle is angle B. The hypotenuse is easy to identify, always opposite the right angle triangle. The right angle. Opposite angle B is side AC. We label that O, and the adjacent side is BC. Okay. Now that we label the triangle, we have to go back and see what we are required to find. We are required to find the adjacent. So we want to solve for A, and we have the hypotenuse and the angle. We have no information for the opposite, and we're not required to solve for the opposite. Therefore, we can totally eliminate and we can totally ignore opposite. So what we're left with is the hypotenuse and adjacent. Then we ask ourselves, okay, which one of the primary trigonometric ratios has opposite and adjacent? And that is cosine. Okay. Then we write that ratio, cosine of angle B equals adjacent over hypotenuse. Substitute the given information and solve the triangle. You can use the pyramid to solve. So cover the letter A, and then you have cosine multiplied by cosine of the angle multiplied by the hypotenuse. Or you can look at this simple linear equation here. Eliminate the denominator by multiplying by 12 both sides, and you're going to have cosine of 25 multiplied by 12 equals to adjacent. All right, so you either can solve directly the equation, or you can use the pyramid to help you properly isolate the variable. Cover A, cosine of the angle multiplied by hypotenuse. Another thing that you need to be aware for the final answer, you need to check where you are asked to round. It's very important, okay? Recall that if the number after, so you're going to look at the hundredth, if that is greater than 5 or greater, you're going to round up. If it is 4 or less, you're going to round down, okay? And these are the steps how we solve right angle triangles. Now, in the following two examples, you are going to stop the video and write down the information, solve them in your own, and come and check the solutions. Okay, again, here, the very first step that you're going to do is label the triangle based on the given angle. Angle B is 10, hypotenuse is 15, and you are to solve for side AC. Okay, after labeling, you are going to eliminate what you don't need, what information is not necessary, adjacent, and which means you're left with sine, and so on. Okay, you're going to do the same for the next example. And all these examples we're solving for the missing side. Now we're going to see what steps we're going to follow if we are solving for the missing angle, when we have to find the angle. Okay, so the steps are very similar to as we followed when we solved for side. However, there is one extra step here. All right, so start by labeling the sides as opposite, adjacent, and hypotenuse. Again, decide which ratio you're going to use by eliminating the side that you don't need. Whatever you left, that is what you are going to that's the information you're going to use to write the ratio. In this triangle, in this specific triangle, we have hypotenuse 8 centimeters. We have opposite 4 centimeters, and we are required to solve this angle theta here. Okay, we have no information for adjacent, therefore we're left with opposite and hypotenuse. Then the proper ratio will be sine. Okay, which one of these three has the hypotenuse and opposite? Sine. All right. The third step, substitute the values that are given to us. So here we have sine of theta equals 4 over 8. 4 over 8. We need to solve for side theta. Remember, when we need to isolate the variable, we do the opposite operation. When we deal with trigonometric ratios, when we solve for angles, the inverse, the opposite operation will be using the inverse of that ratio. Okay, and that's how we write the inverse of a ratio. In this case, we deal with sine, so we're going to have sine, and it's written like to exponent of -1, but it's never read as sine to exponent of -1. We just say the inverse of sine. Okay, pay attention to the notation and how we write it. So to isolate the angle theta here, we're going to take the inverse of sine. Theta equals inverse of sine of the ratio that we have, 4 over 8. Put that into your calculator. Be careful when you plot that into your calculator to use the brackets. So you're going to write it as you see it. Inverse, so second function or shift depending on your calculator. Bracket, if your calculator is forward, 4 divided by 8, close the bracket. It's very important that you do that, otherwise the calculator will do the inverse of 4 multiplied by 8 and you're going to get an error. It's going to give you the given angle. Okay, so these are the steps that you follow when you solve for the missing angle. Very similar to when we solve a missing side up to step 3. And then here we take the inverse. That's the only difference. Okay, now we're going to look at this triangle to illustrate what we just talked about. We have triangle ABC and we asked to solve for side C. Okay, so the very first thing that we're going to do is label this triangle as opposite, adjacent, and hypotenuse. So angle C, side AC is the adjacent, opposite is side AB, and the hypotenuse is side BC. What is given to us is hypotenuse and opposite. No information is given for the adjacent. Therefore, we can eliminate that. That means that we are left with opposite and hypotenuse. Which one of the trigonometric ratios has those two sides? Sine. We can write sine of C equals opposite over hypotenuse. Plot the information that is given to us. And then we need to solve for angle C. We're going to use the inverse of sine of the ratio 6 over 11. Careful as you plot this information to your calculator, and you are going to get the measure of angle C, 33 degrees. Okay, now the next two examples you are going to try by yourself. following the steps as we spoke. Step 1, labeling, identify the ratio, substitute, use the inverse. Okay, and then you can come back and check your solution. Please make sure that you do that. And for both the examples, okay? Following step 1 by 1 here, you can come always and check if you doubt yourself. And then after that, you are going to complete the homework on the textbook on page 8, problems 1, 2, 3A, 4A, 5A, and 7. If you have any questions, please don't hesitate to ask me. Okay, talk to you later.